Hello, welcome to the review of the Chapter 2 Connection to the WAN of the Cisco Network Academy Connecting Networks. First, we're going to review the objectives of the chapter. At the end, we'll be able to describe the purpose of a WAN, describe the WAN operations, the WAN services available, compare various private WAN technologies, compare various public WAN technologies, and select the appropriate WAN protocol and service for a specific network requirement. WAN technologies overview. Businesses must connect local area networks or LANs together to provide communications between them, even when these LANs are far apart. Wide area networks or WANs are used to connect remote LANs together. A WAN may cover a city, country, or global region. A WAN is owned by a service provider, and a business must pay a fee to use the provider's WAN's network services. Different network technologies are used for WANs than for LANs. This chapter will introduce WAN's standards, technologies, and purposes. Without WANs, LANs will be a series of isolated networks. LANs provide both speed and cost efficiency for transmitting data over relatively small geographical areas. However, as organizations expand, businesses require communications among geographically separated sites. The following are some examples. Regional or branch offices must be able to communicate and share data. Organizations must share information with other customers' organizations. Mobile workers must access information that resides on corporate networks. All computer users also need to send and receive data across increasing larger distance. Here are some examples. Consumers communicate over the internet with banks, stores, and a variety of providers of goods and services. Students do research by accessing library indexes and publications located in other parts of the country and in other parts of the world. Purpose of WANs: evolving networks. Companies expect their networks to perform optimally and to be able to deliver an ever-increasing array of services and applications to support productivity and profitability. We're going to use the example of an imaginary company called Span Engineering to show the evolution of the company's network. First, the company will have only a LAN where all the workers are connected to. Then, it will have a campus network where they have several LANs connected to each other. The next step will be a branch network to ensure that all parts of the business are able to access the same service and applications regardless of where the offices are located. The company must now implement a WAN. Connecting to its branch sites may occur over dedicated private lines or by using the internet. For its branch office that is in nearby city, the company decides to use private dedicated lines through their local services provider. However, for its regional office and remote office located in other country, the internet is an attractive WAN connection option. Finally, we have distributed networks. The Span Engineering must reduce its operating expenses. It has reallocated some of its offices facilities to less expensive areas. The company is also encouraging teleworking and virtual teams. The web-based applications, including web conferencing, e-learning, and online collaboration tools, are being used to increase productivity and reduce costs. Site-to-site and remote access virtual private networks, or VPNs, enable the company to use the internet to connect easily and securely with employees and facilities around the world. To meet these requirements, the network must provide the necessary converged services and secure internet WAN connectivity to remote offices and individuals. As seen in this example, network requirements of a company can change dramatically as the company grows over time. Distributing employees saves cost in many ways, but it puts increased demands on the network. Not only must a network meet the day-to-day operations needs of the business, but it must also be able to adapt and grow as the company changes. WANs in the LC model. As shown in the figure, WAN operations focus primarily in the physical layer, also layer 1, and the data link layer, also layer 2. Layer 1 protocols describe how to provide electrical, mechanical, operational, and functional connections to the services of a communication service provider. Layer 2 protocols define how data is encapsulated for transmission towards a remote location and the mechanism for transferring and resulting frames. A variety of different technologies are used, such as point-to-point protocol, frame relay, and asynchronous transfer mode. Some of these protocols use the same basic framing or a subset of the high-level data link control mechanism. Most WAN links are point-to-point. For this reason, the address field in the layer 2 frame is usually not used. As illustrated in the figure, there are various methods and therefore devices that are used to access a WAN connection. Service providers also have specific WAN devices within their networks and devices that are required to interconnect to other WAN providers. In the figure, you can look for dial modem, access server, broadband modem, channel service unit or data service unit, a WAN switch, a router, a core router or multi-layer switch. All these depends on the type of the WAN technology implemented. These WAN technologies are implemented over the either circuit switched or packet switched networks. Circuit switching. A circuit switched network is one that establishes a dedicated circuit or channel between nodes and terminals before the user may communicate. As shown in the figure, circuit switching dynamically establishes a dedicated virtual connection for voice or data between a sender and a receiver. Before communication can start, it is necessary to establish the connections through the network of the service provider. It is important to note that the circuit must remain established and never change or communication will be terminated. The two most common types of circuit switched WAN technologies are public switched telephone networks and the integrated service digital network. Packet switching. In contrast to circuit switching, packet switching splits traffic data into packets that are routed over a shared network. Packet switching networks do not require a circuit to be established, and they allow many pairs of nodes to communicate over the same channel. The routers in packet switching network determine the links that packets must be sent over based on the addressing information in each packet. The following are two approaches to link determination. Connectionless system, that an example will be the internet connection, and connection-oriented system, that an example will be a frame relay. Because of the internal links between the switches are shared between many users, the cost of packet switching is lower than the circuit switching. However, delays or latency and variability of delay or jitter are greater in packet switching networks than in circuit switched networks. This is because the links are shared and because packets must be entirely received at one switch before moving to the next. Despite the latency and the jitter inherent in shared networks, modern technology allows satisfactory transport of voice and video communications of these networks. Selecting a WAN technology. There are several WAN access connections options that an internet service provider can use to connect the local loop to the enterprise edge. These WAN access options differ in technology, speed, and cost. Each has distinct advantages and disadvantages. Familiarity with these technologies is important for network design. In the figure, we can see that it can choose between a private or a public WAN infrastructure. The private WAN service providers may offer dedicated point-to-point layered lines, circuit switched links such as PSTN or ISDN, and packet switched links such as Ethernet WAN, ATM, or frame relay. In the public case, we have may offer a broadband internet access using digital subscribing line, DSL, a cable, and satellite access. Broadband connections are typically used to connect small offices and telecommunicating employees to corporate sites over the internet. Data traveling between corporate sites over the public WAN infrastructure should be protected using VPNs. Service provider network infrastructure. When a WAN service provider receives data from a client at a site, it must forward the data to the remote site for final delivery to the recipient. In some cases, the remote site may be connected to the same service provider as the originating site. In the other cases, the remote site may be connected to a different internet service provider, and the originating ESP must pass the data to the connecting internet service provider. Long-range communications are usually those connections between ESPs or between branch offices in very large companies. Service provider networks are complex. They consist mostly of high-bandwidth fiber optical media using either synchronous optical network or synchronous digital hierarchy standard. These standards define how to transfer multiple data, voice, and video traffic over optical fiber using lasers or light-emitting diodes over great distances. Now we're going to review private WAN infrastructures, starting with leased lines. When permanent dedicated connections are required, a point-to-point link is used to provide a pre-established WAN communications path from the customer premises to the provider network. Point-to-point lines are usually leased from a service provider and are called leased lines. Leased lines have existed since the 1950s, and for these reasons are referred to by different names, such as leased circuits, serial link, serial line, point-to-point link, and T1E1 or T3E3 lines. The term leased lines refers to the fact that the organization pays a monthly lease fee to a service provider to use the line. Leased lines are available in different capacities and are generally priced based on the bandwidth required and the distance between the two connection points. In North America, service providers use the T-carrier systems to define the digital transmissions capability of a serial copper media link, while Europe uses the E-carrier system, as shown in the figure. The advantages of leased lines include simplicity. Point-to-point communication links require minimal expertise to install and maintain. Quality. Point-to-point communication links usually offer high service quality if they have adequate bandwidth. Dedicated capacity removes latency or jitter between the endpoints. Other is availability. Constant availability is essential for some applications such as e-commerce. Point-to-point communication links provide permanent dedicated capacity which is required for voice over IP or video over IP. The disadvantage of leased lines include cost. Point-to-point links are generally the most expensive types of WAN access. The cost of leased line solutions can become significant when they are used to connect many sites over increasing distance. In addition, each endpoint requires an interface on the router, which increases equipment costs. Limited flexibility. WAN traffic is often variable and leased lines have a fixed capacity, so that the bandwidth of the line seldom matches the need exactly. Any change of the leased line generally requires a site visit of the internet service provider personnel to adjust capacity. The layer 2 protocols is usually HDLC or PPP. The next private WAN infrastructure is dial-up. Dial-up WAN access may be required when no other WAN technology is available. For example, a remote location could be used a modem and analog dial telephone lines to provide low capacity and dedicated switched connections. Dial-up access is suitable when intermittent low volume data transfers are needed. Traditional telephony uses a copper cable for the local loop to connect the telephone handset in the subscriber premises of the CO. The signal of the local loop during a call is continuously varying electronic signal that is translation of the subscriber voice into an analog signal. Traditional local loops can transport binary computer data through the voice telephone networks using a modem. The modem modulates the binary data into analog signal at the source and modulates the analog signal to binary data at the destination. The physical characteristics of the local loop and its connection to the PSTN limit the rate of the signal to less than 56 kilobits per second. For small business, These relatively low-speed dial-up connections are adequate for the exchange of sales figures, prices, routine reports, and email. Using automatic dial-up at night or on weekends for a large file transfer and data backup can take advantage of lower off-peak traffics. Tariffs are based on the distance between the endpoints, time of the day, and duration of the call. The advantages of the modem analog lines are simplicity, availability, and low implementation cost. The disadvantages are low data rates and a relatively long connection time. Dedicated circuit has little delay or jitter for point-to-point traffic, but voice or video traffic does not operate adequately at these low byte rates. Next, we'll have ISDN, that is Integrated Service Digital Network. It's a circuit switching technology that enables the local loop of a PSTN to carry digital signals, resulting in higher capacity switched connections. ISDN changes the internal connections of the PSTN from carrying analog signals to time division multiplexed digital signals. TDM allows two or more signals or bit streams to be transferred as subchannels in one communication channel. The signal appears to transfer simultaneously, but physically the signals are taking turns on the channel. And the figure it displays an ISDN topology. The ISDN connection may require a terminal adapter TA, which is a device used to connect ISDN basic rate interface or BRI connections to a router. ISDN turns the local loop into a TDM digital connection. This change enables the local loop to carry digital signals that result in a higher capacity switched connections. The connections uses a 64 kilobits per second mirror channels for carrying voice or data and a signaling delta channel for a call setup and other purposes. There are two types of ISDN, the basic rate interface and the primary rate interface. Frame relay. Frame relay is a simple layer 2 non-broadcast multi-access WAN technology used to interconnect enterprise LANs. A single router interface can be used to connect multiple sites using PVCs. PVCs are used to carry both voice and data traffic between a source and a destination, and support data rates up to 4 megabits per second, with some providers offering even higher rates. An edge router only requires a single interface, even when multiple virtual circuits VCs are used. The short leased line to the frame relay network edge allows cost-effective connections between widely scattered LANs. Frame relay creates PVCs which are uniquely identified by data link connections identifiers, DCLCI. The PVCs and DLCIs ensure bidirectional communications from one DTE device to another. For instance, in the figure, R1 will use the DLCI 102 to reach router 2, while the router 2 will use DLCI 201 to reach router 1. ATM or asynchronous transfer mode technology is capable of transferring voice, video, and data through private and public networks. It's built on a cell-based architecture rather than on a frame-based architecture. ATM cells are always a fixed length of 53 bytes. The ATM cell contains 5-byte ATM header followed by 48 bytes of ATM payload. Small fixed length cells are well suited for carrying voice and video traffic because this traffic is intolerant of delay. Video and voice traffic do not have to wait for larger data packets to be transmitted. The 53-byte ATM cell is less efficient than the bigger frames and packets of frame relay. Furthermore, the ATM cell has at least 5 bytes of overhead for each 48 bytes payload. When the cell is carrying segment networks layer packets, the overhead is higher because the ATM switch must be able to resemble the packets at the destination. A typical ATM line needs almost 20% greater bandwidth than frame relay to carry the same volume of network layer data. ATM was designed to be extremely scalable and to support link speeds of T1, E1 to OC12, that is 622 megabits per second and faster. ATM offers both PVCs and SBCs, although PVCs are more common with WANs, as with other shared technologies. ATM allows multiple VCs on the single list lines connections to the network edge. In the example of the figure, the ATM switch transmits 4 different traffic flows consisting of video, VoIP, web, and email. The next is Ethernet WAN. Ethernet was originally developed to be a LAN access technology. At the time, however, it really was not suitable as a WAN access technology because the maximum capable length support was only up to 1 kilometer. However, newer Ethernet standards using fiber optic cables have made Ethernet a reasonable WAN access option. Service providers now offer Ethernet WAN service using fiber optic cabling. The Ethernet WAN service can go by many names, including Metropolitan Ethernet, Metro E, Ethernet over MPLS, and virtual private LANs. The benefits of Ethernet WAN include reduced expenses and administration. Ethernet WAN can provide a switched high bandwidth layer 2 network capable of managing data, voice, and video all on the same infrastructure. This characteristic increase bandwidth and eliminate expensive conversions to other WAN technologies. The technology enables businesses to inexpensively connect numerous sites in a metropolitan area to each other to the internet. Other characteristic and advantage is easy integration with existing networks. Ethernet WAN connects easily to existing Ethernet LANs, reducing installation cost and time. Also, it has enhanced business productivity. Ethernet WAN enables businesses to take advantage of productivity-enhancing IP applications that are difficult to implement on TDM or frame relay networks, such as hosted IP communications, voice over IP, and streaming and broadcast video. Other technology is the multi-protocol label switching, MPLS. It's a multi-protocol high-performance WAN technology that directs data from one router to the next based on short path labels rather than IP network addresses. MPLS has several defining characteristics. It is multi-protocol, meaning it has the ability to carry any payload including IPv4, IPv6, Ethernet, ATM, DSL, and frame relay traffic. It uses labels that tell a router what to do with a packet. The label identifies paths between distant routers rather than endpoints, and while MPLS actually routes IPv6 and IPv4 packets, everything else is switched. MPLS is a service provider technology. Listed lines deliver bits between sites, and frame relay and Ethernet WANs deliver frames between sites. However, MPLS can deliver any type of packet between sites. MPLS can encapsulate packets of various network protocols. It supports a wide range of WAN technologies including T-carrier, E-carrier links, carrier Ethernet, ATM, frame relay, and DSL. Notice that different sites can connect to the MPLS cloud using different access technologies. In the figure, CE refers to the customer edge. PE is a provider edge router, which adds and removes labels, while P is an internal provider router, which switches MPLS labeled packets. Now we have VSAT. All private WAN technologies discussed so far use either copper or fiber optic media. What if an organization needs connectivity in a remote location where there are no service providers that offer WAN service? Very Small Aperture Terminal, or VSAT, is a solution that creates a private WAN using satellite communications. A VSAT is a small satellite dish similar to those used for home internet and TV. VSATs create a private WAN while providing connectivity to remote locations. Specifically, a router connects to a satellite dish that is pointed to a service provider's satellite in a geosynchronous orbit in space. The signal must travel approximately 35,000 kilometers to the satellite and back. The example in the figure displays a VSAT dish on the roofs of the building communicating with a satellite dish thousands of kilometers away in space. Now we're going to discuss public WAN interfaces. We're starting with DSL. DSL technology is an always-on connection technology that uses existing twisted pair telephone lines to transport high bandwidth data and provides IP services to subscribers. A DSL modem converts an internet signal from the user device to a DSL signal, which is transmitted to the central office. Multiple DSL subscriber lines are multiplexed into a single high-capacity link using a DSL access multiplexer at the provider location. DSLAMS incorporate TDM technology to aggregate many subscriber lines into a single medium, generating generally a T3 connections. Current DSL technologies use sophisticated coding and modulation techniques to achieve fast data rates. There is a wide variety of DSL types, standards, and emerging standards. DSL is now a popular choice for enterprise IT departments to support home workers. Generally, a subscriber cannot choose to connect to an enterprise network directly, but must first connect to an internet service provider, and then an IP connection is made through internet to the enterprise. Security risks are incurred in this process, but can be mediated with security measures. In the figure, we show a normal topology displaying a sample DSL1 connection. Now we want to review the cable. Coaxial cable is widely used in urban areas to distribute television signals. Network access is available from many cable television providers. This allows for greater bandwidth than the conventional telephone local loop. Cable modems provide an always-on connection and a simple installation. A subscriber connects a computer or LAN router to the cable modem, which translates the digital signal into the broadband frequencies used for transmitting on a cable television network. The local cable TV office, which is called the cable headend, contains the computer systems and databases needed to provide internet access. The most important component located at the headend is the cable modem termination system, CMTS, which sends and receives digital cable modem signals on a cable network and is necessary for providing internet services to cable subscribers. Cable modem subscribers must use the internet service provider associated with the service provider. All the local subscribers share the same cable bandwidth. As more users join the service, available bandwidth may be lower than the expected rate. Now we're going to review wireless. Wireless technology uses the unlicensed radio spectrum to send and receive data. The unlicensed spectrum is accessible to anyone who has a wireless router and a wireless technology in the device they are using. Until recently, one limitation of wireless access has been to the need to be within the local transmission range, typically less than 100 feet, of a wireless router or a wireless modem that has wire connections to the internet. The following new developments in broadband wireless technology are changing this situation. For example, now we have municipal Wi-Fi. Many cities have begun setting up municipal wireless networks. Some of these networks provide high-speed internet access for a free or substantially less than the price of other broadband services. Others are for city use only, allowing police and fire departments and other city employees to do certain aspects of their jobs remotely. To connect to municipal Wi-Fi, a subscriber typically needs a wireless modem, which provides a stronger radio and directional antenna than a conventional wireless adapter. Most services providers provide the necessary equipment for free or for a fee. much like they do with DSL or cable modems. Other wireless, we have Wi-Fi, a worldwide interoperability for microwave access. Is a new technology that is just beginning to come into use. It is described in the IEEE standard 802.16. WiMAX provides high-speed broadband service with wireless access and provides broad coverage like a cell phone network rather than through small Wi-Fi hotspots. WiMAX operates in a similar way to Wi-Fi, but at a higher speeds, over greater distances, and for a greater number of users. It uses a network of WiMAX towers that are similar to cell phone towers. To access a WiMAX network, subscribers must subscribe to an internet service provider with a WiMAX tower within 30 miles of their location. They also need some type of WiMAX receiver and a special encryption code to get access to the base station. Other wireless media is the satellite internet, typically used by rural users where cable and DSL are not available. A VSAT provides two-way upload and download data communications. The upload speed is about 1/10 of 500 kilobits per second download speed. Cable and DSL have higher download speeds, but satellite systems are about 10 times faster than analog modem. To access satellite internet service, subscribers need a satellite dish, two modems, uplink and downlink, and coaxial cables between the dish and the modem. 3G and 4G cellular. Increasingly, cellular service is another wireless WAN technology being used to connect users and remote locations where no other WAN access technology is available. Many users with smartphones and tablets can use cellular data to email, surf the web, and download apps and watch video. Phones, tablet computers, laptops, and even some routers can communicate through the internet using cellular technology. As shown in the figure, these devices use radio waves to communicate through a nearby mobile phone tower. The device has a small radio antenna, and the provider has a much larger antenna sitting at the top of a tower somewhere within miles of the phone. Common cellular industry terms include 4G or 3G wireless, abbreviation of third generation and fourth generation cellular access. These technologies support wireless internet access. Other term is long-term evolution, or LTE, refers to a newer and faster technology and is considered to be part of fourth generation technology. VPN technology. Security risks are incurred when a teleworker or a remote office worker use broadband services to access the corporate WAN over the internet. To address security concerns, broadband services provide capabilities for using VPN connections to VPN server, which is typically located at the corporate site. A VPN is an encrypted connection between private networks over a public network, such as the internet. Instead of using a dedicated layer 2 connection such as leased line, or a VPN uses virtual connections called VPN tunnels, which are routed through the internet from the private network of the company to the remote site of the employee host. Benefits of VPN includes the following. Cost saving. VPNs enable organizations to use global internet to connect remote offices and remote users to the main corporate site, thus eliminating expensive dedicated WAN links and modem banks. Security. VPNs provide the highest level of security by using advanced encryption and authentication protocols that protect the data from unauthorized access. Scalability. Because VPNs use the internet infrastructure within the internet service providers and devices, it is easy to add new users. Corporations are able to add large amounts of capacity without adding significant infrastructure. Compatibility with broadband technology. VPN technology is supported by broadband services providers such as DSL and cable, so mobile workers and telecommuters can take advantage of their home high-speed internet service to access their corporate networks. Business-grade high-speed broadband connections can also provide a cost-effective solution for connecting remote offices. There are two types of VPN access: site-to-site VPNs. Site-to-site VPNs connect entire networks to each other. For example, They can connect a branch office network to a company headquarters network. As shown in the figure, each site is equipped with a VPN gateway such as a router, firewall, VPN concentrator, or a security appliance. In the figure, a remote branch office uses a site-to-site VPN to connect with the corporate head office. The other example is a remote access VPN. Remote access VPNs enable individual hosts such as a telecommunicator, mobile user, and external consumers to access a company network securely over the Internet. Each host, Teleworker 1 and Teleworker 2, they typically has two VPN client software loaded or used a web-based client. Choosing a WAN link connection. There are many important factors to consider when choosing an appropriate WAN connection. For a network administrator to decide which WAN technology best meets the requirements of their specific business, they must answer the following questions. What is the purpose of the WAN? Considerations include: will the enterprise connect local branches in the same city area, connect remote branches, or connect to Signal branch? Will the WAN be used to connect internal employees or external business partners and customers, or all the three? Will the enterprise connect to customers, connect to business partners, connect to employees, or some combination of these? Will the WAN provide authorized users limited or full access to the company intranet? The other question is, what is the geographical scope? Considerations include: is the WAN local, regional, or global? Is the WAN one-to-one single branch, one-to-many branches, or many-to-many distributed? The other question is, what are the traffic requirements? Considerations may include: what type of traffic must be supported, what volume of traffic type must be supported for each destination, what quality of service is required, what are the security requirements. In addition to gathering the information about the scope of the WAN, the administration must also determine that should the WAN use a private or public infrastructure. For a private WAN, should it be dedicated or switched? For a public WAN, what type of VPN access is required? Also, which connection options are available locally? And finally, what is the cost of the available connection options? Well, that's all for today. We have finished chapter 2 of connecting networks of Cisco. So, see.